our topic for today is solving systems of linear inequalities. So I would like you to pay your attention to the following words. It's systems, it's linear, and inequalities. First, when we have systems, it means that we have two or more inequalities involved in it that we have to solve simultaneously. Second, linear means that the variables, both independent and dependent, they are involved in these inequalities in the linear form. So which means that you might have only the linear combination of the variable x and y, exactly as you have here in this example given to you. So we see that 5 is multiplied by x, so there is no x squared or square root of x, it's just x. And then we have here minus 2y, where y is also just y. There is no y squared, there is no square root of y. So this inequality right here, we call it a linear inequality because both x and y are given to us here in this inequality in a linear form. Also, I want you to pay attention to the second inequality. It is linear as well because x and y, they just form the linear combination because you have a summation of x and y, and then x is multiplied by 3, and then y is just multiplied by 2. However, you see that these two inequalities differs. So here you have this non-strict inequality, and the second is a strict inequality. What does it mean? In the first case, when you have less or equal than, it means that the solution might satisfy the following conditions. So that left-hand side may be less, strictly less than 10, or equal to 10. So you have two opportunities here, less, strictly less than 10, or equal to 10. Here, in the second inequality, you have a strict inequality, and it's strictly greater than 6. So if at some point your left-hand side is equal to 6, it will be not the solution to this inequality because you have a strict inequality. So all the values that are greater than 6 will be good, but not the values that are equal or less than 6. Okay, dear students, so let's try to solve this system of two inequalities. And there is a very good approach that helps us to solve this system effectively. And we call it just a graphical method, which means that we will be drawing the solution to the inequality number 1, and then we'll be drawing the solution to the inequality number 2. And this system means here that these two inequalities have to be satisfied simultaneously, which means that we will be looking for the intersection between the solution to the inequality number 1 and to the solution for the inequality number 2. So the intersection gives us this kind of and condition. So these and these both have to be satisfied simultaneously. So that word and in mathematics is always denoted by intersection operation. So for convenience, dear students, let's then denote this top inequality by 1 and this bottom inequality by 2. So first, I would like to solve the inequality number 1. So how do we do that? How do we solve this inequality graphically? So first, let me write down this inequality right here, dear students. So we have 5x minus 2y less or equal 10. So how do we solve it graphically, dear students? First of all, we have to draw the Cartesian coordinates, dear students. So we put here x-axis, y-axis, and here in the middle the origin. So how do we solve this inequality? First of all, dear students, I know that all of you know how to draw just the equation, or actually the linear function, which is 5x minus 2y equal 10. So first we will be drawing just the equality, or just the linear function, which is a straight line, and which is 5x minus 2y equal 10. First, to make it easier, dear students, probably I will just try to get the representation of this y function explicitly. So what I'll be doing, I'll be isolating y in the left-hand side. So then we will get 10 minus 5x. And now we will be dividing the whole equation by minus 2. So that will give us y equal minus 5 plus 5 halves x. Very good, dear students. So let me take it in the box, and that equation in the box is exactly our straight line that corresponds to inequality number 1. So let's draw it. I know that you all know that for us to draw a straight line, we just need at least 2 points. So I'll be picking only 2 points. The first point, which is very easy to pick, is when x is equal to 0. So let me just take it right here. When x is equal to 0, our y value will be minus 5. And then when x is equal to, our y value will be 0. So we have 2 points, dear students. We have 0 minus 5. So here is 0, 1, 2, 3, 4, 5. So here is minus 5. So that point will be right here. And another point is 2, 0. So we have 1, and then here are 2. So 2, 0 is right here. So our dear students, our first straight line that corresponds to the inequality number 1 will look exactly like this. So dear students, let me tell you, so here we drew the condition or the case when 5x minus 2y is exactly equal to 10. And you see that this inequality is not the strict, so we allow the 10 value in it. So that's why I made this line as a solid line, not as a dash line. So we have the solid line because 10 is included. And now to draw a solution for this inequality number 1, we need to know what side of the line we have to shade. Is it the left-hand side will be all the points that satisfy this inequality, or will it be all the right-hand side points that will satisfy this inequality? So to check it easily, dear students, we just have to take one sample point from either side, plug it into this inequality and check. If the inequality holds, then this point satisfies it, and it means that we have to shade that appropriate side. If that point that we pick don't satisfy this inequality, I mean, it's like inequality does not hold, then we have to shade another side. So let's check. The easiest way to check is just pick, for instance, this origin point, which has coordinates 0 and 0. If we plug 0 and 0 into this inequality, what we will get? We will get 5 times 0, which is 0, minus 2 times 0, which is 0. So all together here, the left-hand side will give us 0, and it's less or equal than 10. Is it true? Yes, it's true, because 0 is less or equal than 10, which is great. So it means, dear students, that left-hand side here is exactly the solution to our inequality number 1. So let me summarize it one more time. So the solution to the inequality number 1 will be the following. It will be that shaded region, pink shaded region, all together with all the points on this straight line. Why? Because we do not have a strict inequality. We have the 10 to be included into the solution, the 10 value. So all the points that lies on the straight line, if you plug them in this inequality, they will give you, in this left-hand side, they will give you 10 value, which is equal to 10, so it holds. Very good. So now similarly, dear students, we deal with the inequality number 2. So which inequality did we have? We had 3x plus 2y greater than 6. So now, dear students, we will just do the same thing. We try to isolate y right here. And first of all, I forgot to tell you that again, we consider this situation, this case, when we have here an equality. It helps us just to draw that initial straight line, and then according to that straight line, we will be able to choose, is it the left or the right hand side? Is it the top or the bottom side? So it's like a border, dear students. You can imagine it as to be a border. So again, let's isolate y in this second inequality. Equality, so we will get 6 minus 3x, and I will just divide everything by 2, so we will get 3 minus 3 halves x. So this is, dear students, our another straight line which corresponds to the second inequality. So how to draw this line, dear students? How to draw? We again need just 2 points. So how do we find these points, dear students? We just take 2 random values for x, and then we will calculate the appropriate y value. So again, it's very easy to pick a 0 value for x. So then y will equal 3. And then it's easy to pick the 2 value for x, and then y will equal 0. So let's put these 2 points on our graph. So we have 0, 3, 0, 3, yes. So it's 0, 3. So it will be right here. And another point is 2, 0, which is right here. You see, it's the same point. Very good. So now, dear students, we have to be careful how we draw our straight line. In this case, the straight line will be not a solid, it will be a dashed straight line, because this inequality is not as it's a strict inequality, so 6 value is not included. So that's why we have to make this line to be dashed. Okay, so how to draw it? We just draw it like this. Okay, dear students, very good. We are done with the part 1 for that second inequality. Now, again, as for inequality number 1, we have to shade the left or the right hand side of that dashed line. So let me maybe use a little bit of notation here. So I'll just do the following. So that was number 1, and that is number 2. So we will just know what is what on this picture. Okay, dear students. So let's shade the appropriate side for that inequality number 2. So again, we have 2 choices here, dear students. We have this left-hand side, or we have this right-hand side. Which one do we have to choose? Again, let's take the origin, dear students. So if we take the origin point, which is 0, 0, and we will plug in this inequality, what we will get? We will get 0 plus 0, which is 0, greater than 6, which is not true. So 0 does not belong to the set of solution. So 0 is not, it does not belong to the domain, like solution domain. So this side is not good, it's not the solution. So there is no more choice for us rather than to choose that side, and that will be a solution. And you check yourself, you can pick any point that belongs to that domain, to that part of the Cartesian coordinates, and you will check that that inequality will be satisfied. So what we have to do now, dear students, we have to shade this region, the solution. Okay, very good. So the solution to the second inequality will be only this brown shaded region. The straight line here is not included, dear students. So now, to find the solution of this system of these 2 inequalities 1 and 2, we need to have we need to find the intersection of these 2 shaded regions. So how to find the intersection? We need to find that common place where these 2 shaded regions are present. So let's see. This one does not work because there is no brown color. Here we have them, none of them. Neither the pink, nor the brown color is presented here. Here we do not have the pink color. So the only region where we see them both is right here. So it's that brown color here and that pink color here. And then let's see. So we see that this part of the line, actually the pink and the brown, belongs to the same region. So that part of the line will be also included into our solution. So dear students, let me then draw that solution for our system of inequalities. So I will make it a little bit more, let's see, I'll make it a little bit more thicker so we will see it on the picture. And let's see. So the solution will be the following. This is the solution, that line, which is, it belongs to both pink shaded region and it belongs also to the brown shaded region. And then, dear students, it will be only that region right here, which belongs to both, but not that dashed line. The dashed line is not included. Why? Because it doesn't belong to the brown region. It only belongs to the pink region, but not to the brown region. Okay, so we see that the intersection will be formed by that green region. And that is exactly the intersection of the two solutions for the inequality 1 and for the inequality 2. So the green region is exactly the solution to the system of two linear inequalities given in this example. That's it, dear students. I hope you found this example to be very useful. Thank you very much for your attention. If you're interested in me explaining more topics in mathematics, please subscribe for my channel and I will see you soon.